How do you approach answering system design interview questions? System design interview questions typically require a structured approach to showcase problem-solving skills and depth of understanding. When answering system design interview questions, follow a structured approach. Here's a step-by-step guide. Step 1. Clarify requirements. Begin by seeking clarification on the requirements. Understand the goals, constraints, and any specific features that the system needs to support. Step 2. Define the scope. Clearly define the scope of the system. Identify the key components and functionalities required to meet the specified goals. Step 3. Identify key components. Break down the system into key components, such as servers, databases, APIs, and external services. Discuss the purpose and interactions of each component. Step 4. Address scalability. Scalability is crucial. Discuss how the system can handle increased load, whether through horizontal scaling, load balancing, or other strategies. Step 5. Consider fault tolerance. Account for potential failures in the system. Discuss redundancy, replication, and fault-tolerant mechanisms to ensure continuous operation. Step 6. Choose appropriate data storage. Select the right data storage mechanisms based on the requirements. Discuss the choice of databases, caching strategies, and considerations for data consistency. Step 7. Discuss algorithms and data structures. Touch upon the algorithms and data structures relevant to the system design. Consider how efficient algorithms can impact the performance of the system. Step 8. Security considerations. Address security concerns such as data encryption, access controls, and measures to protect against common security threats. Step 9. Optimizations and trade-offs. Discuss potential optimizations and trade-offs in the design. Consider factors like response time, storage efficiency, and development complexity. Step 10. Real-time considerations. If applicable, discuss how the system handles real-time requirements. This might involve considerations for streaming data, event-driven architectures, or real-time analytics. Step 11. Review and iterate. Regularly review your design as you discuss it. Be open to feedback and iterate on your design based on the interviewer's input. Step 12. Summarize and conclude. Summarize your design, highlighting key decisions and trade-offs. Conclude with confidence, reiterating how your design effectively meets the specified requirements. Remember, communication is key. Clearly articulate your thought process, and don't hesitate to ask for feedback or clarification during the discussion. Demonstrate a logical and systematic approach to problem solving, and showcase your ability to think critically about system architecture. Commonly asked basic and technical system design interview questions with sample answers. Can you explain the concept of system design? System design involves creating a blueprint for a complex entity, detailing its architecture, components, modules, interfaces, and data for meeting specified requirements. It encompasses the process of defining the structure and behavior of the system to achieve desired functionalities efficiently. How does system design work? And what is the purpose of employing system design? System design works by systematically breaking down the components of a system, analyzing their interactions, and defining their specifications. It involves iterative planning, detailing, and refining to ensure the design system meets its intended goals, adhering to performance, scalability, and maintainability criteria. System design is used to systematically plan and structure complex systems, ensuring they meet specified requirements efficiently. It aids in minimizing risks, optimizing performance, and creating a roadmap for implementation, resulting in well-organized and functional systems. What data structures would you use to store cached web pages? For caching web pages, consider using a combination of a hash table and a doubly linked list. The hash table allows for efficient lookups by URL, while the doubly linked list facilitates quick removal and insertion of pages based on access patterns, optimizing both retrieval and eviction operations in constant time. What is sharding? Sharding is a database architecture strategy that involves partitioning a large database into smaller, more manageable, and independent pieces called shards. Each shard is a self-contained database that stores a subset of the overall data. This distributed approach helps improve performance, scalability, and efficiency in handling large volumes of data and concurrent transactions. How would you distribute cache across multiple servers for scalability? Implement consistent hashing to distribute the cache across multiple servers. This ensures a balanced distribution of keys, minimizing reshuffling when servers are added or removed. Each server is responsible for a specific range of keys, enabling horizontal scalability and efficient cache management in a distributed environment. How to create a fault-tolerant database system with data replication and consistency mechanisms. A fault-tolerant database employs data replication across multiple servers, ensuring redundancy. Consistency is maintained using techniques like two-phase commit or quorum-based systems. Automated failover mechanisms, regular backups, and robust error handling enhance system resilience. Can you describe the structure of a CDN and elaborate on its advantages? The Content Delivery Network, CDN, architecture involves strategically placed edge servers worldwide, storing cached content. This geographically distributed approach accelerates content delivery, reduces latency, and minimizes server load. Benefits include improved website performance, enhanced user experience, and efficient handling of traffic spikes. Can you detail the components and challenges in a microservices architecture? Microservices consist of independently deployable services communicating via APIs. Components include service registry, load balancing, and message brokers. Advantages include scalability and flexibility, but challenges involve inter-service communication, data consistency, and increased operational complexity. Explain the design of a system to prevent and handle distributed denial of service, DDoS, attacks. Implement traffic filtering, rate limiting, and use of content delivery networks, CDNs. Employ anomaly detection algorithms to identify abnormal traffic patterns. Scale resources dynamically and leverage cloud-based solutions for robust DDoS mitigation. How to design a distributed file system capable of efficient large-scale storage and retrieval. Utilize a distributed architecture with replicated and sharded storage. Implement a distributed file system like Hadoop Distributed File System, HDFS, for fault tolerance and scalability. Consider data partitioning and load balancing for optimal performance. Can you devise a scalable algorithm for real-time trending topics in a social media platform? Implement a streaming algorithm that tracks hashtags and engagement metrics. Prioritize recent and rapidly growing topics, considering time decay. Use efficient data structures like priority queues for quick updates and retrieval, ensuring real-time responsiveness. Explain the principles and components of a message queue system for asynchronous communication. Message queues facilitate asynchronous communication between distributed components. Components include message producers, queues, and consumers. Ensure reliability with features like acknowledgements and retries. Scalability is achieved through distributed queues and horizontal scaling. Discuss the design considerations for a recommendation system based on machine learning models. Integrate collaborative filtering or content-based filtering algorithms. Utilize user item matrices and employ techniques like matrix factorization. Consider model training, feature engineering, and real-time updates for personalized and accurate recommendations. Design a system to handle user authentication and authorization in a distributed environment. Implement a distributed authentication service with secure token exchange. Use OAuth or OpenID Connect for authorization. Employ role-based access control, RBAC, for fine-grained permissions. Ensure secure communication and centralized user management. Design a logging and monitoring system for a large-scale distributed application. Implement centralized logging with tools like ELK, Elasticsearch, Logstash, Kibana. Use distributed tracing for monitoring transaction flows. Employ alerting mechanisms for anomaly detection. Ensure scalability and fault tolerance with redundant logging servers and distributed monitoring nodes. What are some prevalent errors in system design? Common system design errors include inadequate scalability planning, overlooking fault tolerance mechanisms, poor data modeling leading to inefficient queries, and insufficient consideration of security measures. Additionally, neglecting to address latency issues, improper load balancing, and overlooking the impact of high concurrency can result in suboptimal system performance and reliability. Comprehensive system design should anticipate and mitigate these errors to ensure robust and scalable architectures. Design a URL shortening service like bit.ly. To design a URL shortening service, we need a scalable and fault-tolerant system. The main components include a web server, a database for storing mappings between short and long URLs, and a unique ID generator. The system should handle a large number of requests efficiently. We can implement a distributed architecture, with load balancing to distribute traffic among multiple servers. To ensure fault tolerance, data replication and regular backups are crucial. Additionally, optimizing the redirection process by minimizing database lookups and caching frequently accessed URLs will enhance performance. Discussing these aspects will demonstrate a comprehensive understanding of system design principles. How would you handle real-time messaging between users? To facilitate real-time messaging between users, follow these steps. WebSocket implementation. Utilize WebSocket for bidirectional communication, ensuring low-latency real-time updates. User authentication. Implement a robust user authentication system to secure messaging channels. Message queues. Integrate message queues to manage message delivery asynchronously, ensuring scalability. Presence management. Implement a presence system to indicate user online-offline status. Channel architecture. Create channels for users to exchange messages, supporting one-on-one and group conversations. Message encryption. Prioritize end-to-end encryption to secure message content during transit. Offline messaging. Implement a mechanism to store and deliver messages when users are offline. Push notifications. Integrate push notifications to alert users of new messages when the application is in the background. Load balancing. Employ load balancing to distribute messaging traffic evenly across servers for scalability. Monitoring and scaling. Implement monitoring tools to track system performance and scale resources as needed for growing user bases.